When we look up at a giant airplane soaring through the sky, we see a marvel of engineering. Its powerful engines and sleek wings are easy to spot, but hidden inside is another amazing system, one that works like the muscles of the aircraft. This is the hydraulic system. It uses pressurized fluid to move heavy parts with incredible force and precision. Without this hidden power, the massive jets we know today simply could not fly. The story of aviation is deeply connected to the story of hydraulics, a technology that transformed simple flying machines into the complex giants that connect our world. It all started with a simple idea, using liquid to do the heavy lifting. In the early days of flight, airplanes were small and lightweight. Pilots controlled them using a series of cables and pulleys, much like operating a puppet. They had to use their own physical strength to move the control surfaces on the wings and tail. This system worked for the small planes of the 1920s. But as designers dreamed of bigger and faster aircraft, a problem emerged. The forces required to move the larger control surfaces became too much for a single person to handle. A new solution was needed, and engineers found it in hydraulics. Early hydraulic systems were first used for simple tasks like operating the brakes, making landings safer and more controlled. The real breakthrough came when engineers began using hydraulics to control the primary flight surfaces, the ailerons, elevators, and rudder. This shift from purely mechanical systems was a game-changer. Instead of pulling long, heavy cables, a pilot could now move a small lever in the cockpit. This lever would open a valve, sending high-pressure hydraulic fluid through strong pipes to a piston. The piston would then move with immense force, pushing or pulling the control surface into position. This made flying much less physically demanding. Pilots no longer had to be bodybuilders to control their aircraft, allowing them to focus more on navigation and a smooth flight. This innovation did more than just make the pilot's job easier, it made flying fundamentally safer and more reliable. Mechanical cables could stretch, fray, or even snap under stress, leading to a loss of control. Hydraulic systems enclosed in durable pipes were far more robust. They provided a smooth, consistent response that pilots could depend on. The introduction of hydraulic power meant that an airplane's muscles were now stronger and more reliable than ever before. This newfound strength and precision opened the door for designers to think bigger, paving the way for the next generation of aircraft that would soon fill the skies. As the 1930s and 1940s rolled in, airplane design took a giant leap forward. Engineers were building much larger and heavier aircraft, like the first big bombers and passenger airliners. These planes flew faster and higher than ever before. With their increased size and speed came much larger wings and control surfaces. A pilot using a simple cable system would have found it impossible to move these massive parts against the powerful rush of air. Hydraulics became the essential technology that made these new aviation giants possible. The power of pressurized fluid was the only practical way to give pilots the strength they needed to command these powerful machines. The application of hydraulics expanded rapidly beyond just the primary flight controls. Think about the landing gear of a large airplane. It is incredibly heavy, and must be tucked away neatly into the fuselage after takeoff to reduce drag. Hydraulics provided the perfect solution. With the flip of a switch, powerful hydraulic actuators would effortlessly fold the heavy wheels and struts into the plane's belly. The same technology was used for wing flaps, which are extended during takeoff and landing to create more lift at slower speeds. Hydraulics allowed for the smooth and precise movement of these critical components, making flight safer and more efficient.